So since I'm out of class and Mr. Broadbelt is out of class today, we're going to give you some help for the photoelectric effect CER. The first thing we're going to do is answer question number 1. The second thing you're going to do is watch the Ed Puzzle video and then answer question number 3. So the next section is writing out the evidence, which is what you saw in the simulation. And so we saw a few things, and I'm going to go over them now. First was just when the light hit the metal plate, it gave off some particles. Then we moved it to the left a little bit to go into UV, and the particles came off a lot faster. The next thing we did was move it further over to the right, longer wavelengths of visible light, and the particles moved more slowly. The last thing we saw was when we got to 541 nanometers and above, no particles came out at all. Okay, reasoning. This is the hard part. So the first thing I want you to think about is what an atom looks like. And you guys can obviously Google what an atom looks like. Here's how I'm going to draw it. We have our protons, which are positively charged and inside the nucleus. And then we have our neutrons, which are neutral, and they act as a buffer for the protons because protons have the same charges, and so they repel one another. So they're just kind of a buffer. And then we have the electrons. They are outside the nucleus and moving around it really fast, and we don't really know how they move, so we just kind of squiggle it around. Once you've thought about the structure of the atom, you need to think about which subatomic particle, protons, neutrons, or electrons, does the light actually interact with? And how does that light being absorbed by the particle make it leave the atom with UV and parts of the visible spectrum, but it does not leave with light at wavelengths of 541 or higher? This is tough. I really want you to think about it and just kind of take a chance. As long as you can justify your answer with evidence, we're good.